Okie dokie. So now we're going to talk about parallelograms. So a parallelogram, definitions in this top left box here. Parallelogram is a quadrilateral that has two sets of parallel sides. Remember, this symbol here means parallel. Make sure you mark that if you don't know what that means. So a quadrilateral. Again, this is where I made the mistake last note. A quadrilateral, that's our four-sided polygon. Now remember, with polygons, no curves. No curves. Only straight lines. So we know a parallelogram has four sides. It also has two sets of parallel sides. That means the sides across from each other never meet. I'm gonna have to either write smaller here or make the lines longer. Okay. Sides across from each other and never meet. I'll make this a little bigger there. Okay, so parallelogram, quadrilateral with two sets of parallel sides. I put a little tip in here. A parallelogram is like a leaning rectangle. Parallelogram is like a leaning rectangle. I have pictures here. You see there's a rectangle on the left and then an arrow pointing to the right. All we did is make it look a little bit lopsided, but they're pretty much the same. Now we need to go over some vocab really quickly. Vocab recall. What does congruent mean? I hope all of you remember this from last semester. There's a symbol for it. Looks like that. If you were in Mr. Goodwin's class with me, we called that the toothpaste. It means the same or equal. I'm gonna write the same. It means that they are exactly the same. Supplementary. If something is supplementary, another one we used a ton last semester, means adds to 180. Adds to 180 degrees. Okay, consecutive. I have a feeling a lot of people are not going to remember this one. We did go over it, but not a lot. Consecutive, we talked about consecutive angles. That's what we'll be talking about here too. I like to think of it as neighbors. It's like neighbors, so that means that they're next to each other. So if I'm talking about this angle right here, it's either going to be the one right next to it, this one, or the one right next to it, this one. Not the one across from it. They have to be neighbors. Opposite. When we're talking opposite angles, we're thinking across. So same thing, if we have a rectangle and we're talking about this top angle, the one straight across from it, not a neighbor. It's like your neighbors on your corners. Bisect, we learned segment bisector and we learned angle bisector. Think about what those words meant. Segment bisector and angle bisector. We're gonna write split in the middle. Split in the middle. I'll give you a second to write that down. We'll zoom out here. So next we're going to be talking about different theorems here, but these theorems are only for parallelograms. You can't use these theorems unless you know for a fact something is a parallelogram. Notice I wrote if it is a parallelogram and you are told it is. I want you to circle, you are told it is. Remember, we never assume. Never assume. So you have to know that it's a parallelogram to use any of these. So we're going to write out these definitions first and then talk about what they mean. So let's just go one at a time here. Theorem 6-3 means if you have a parallelogram, opposite sides are congruent. Opposite sides are congruent. So let's name these corners here. We'll name it A, B, C, D. If I tell you that this, from A to B, the measure here, from A to B, that's what we mean when we write AB. AB. From A to B. If I tell you that measure is 5, what's the measure of DC, from D to C? That's going to also be 5. Think of a rectangle. The top and bottom of a rectangle are equal. We're just making it lopsided. So AB is congruent to DC or CD, however you want to write that. AB is congruent to DC. Remember, these symbols above it mean segments. We can do the same thing with the sides here. If I tell you this first one is 2, then you better be able to tell me BC over here is 2. So AD is congruent to BC. So that one's not too bad. Opposite sides are congruent. It just means the ones, remember, opposite across from each other. Opposite sides are congruent. Next, if we have a parallelogram, Theorem 6-4 says consecutive angles are supplementary. Consecutive angles are supplementary. All right, consecutive angles are supplementary. Again, if we have parallelogram A, B, C, D here, think consecutive angles. So let's pick an angle. Let's do A. This angle, angle A, is consecutive to its neighbor angles, right? Consecutive means neighbors. Let's pick this one. This means angle A plus angle B equals 180. Now time out. Isn't it also neighbors with this one? That means you could also have said angle A plus angle D equals 180. Consecutive just means neighbor. You could pick either neighbor. That leads us into our next one here. Theorem 6-5. If we have a parallelogram, then opposite angles are congruent. Notice I write out congruent. Sometimes I put the toothpaste thing. Hopefully you know what both of those mean. Write them how you're going to remember. So we have parallelogram A, B, C, D. Again, opposite angles are congruent. I'm going to pick B fun this time. Let's pick angle B. What's the opposite angle to angle B? Remember, opposite, not neighbors. We want cross. So this means angle B is congruent to angle D. Now, We kind of knew that already because we know these angle A's are the same here. So don't these also have to be the same in order for them to equal 180? You can't put two different numbers. So angle B is congruent to angle D. You also can say angle A is congruent to angle C. You could flip-flop them all you want. That one's not that bad either. All right, one more. If we have a parallelogram, diagonals bisect each other. Diagonals bisect each other. A diagonal. Remember, this way is vertical. This way is horizontal. So diagonal is probably going to be one of the other ones, one of our X ones. We go corner to corner. Ooh, where did we go? What did we do here? We don't want that. Go away. Oh man, we really messed this up. Let's fix this. All right, saved. Thank goodness. If you had me last semester, you know I'm really bad with technology, so that's not very surprising. Okay, diagonals bisect each other. So vertex to vertex or corner to corner, that is a diagonal. Oh, let's label our points here. A, B, C, D. That's one diagonal. Corner to corner, here's our other diagonal. Kind of looks like a kite. Maybe that's just me. Or it looks like an X. They bisect each other. What did bisect mean? Bisect meant split in the middle. So from A to C, I split it in the middle. That means this side and this side are the same. Right? Because it's split in the middle. That also means this side and this side are the same. Remember, when the markings are the same, that means they are equal or congruent. So let's give this middle one a name. Let's call it E. That's an E. It's bad E, but it's an E. So we have from A to E. Oop, that's way too small. What? From A to E, or segment AE, is congruent to segment EC. Right? From A to E is the same distance as from E to C. That's what splitting through the middle means. We can do the same thing with DE and EB, right? They're split in the middle too. Goes for both diagonals, so we'll always have those be the same. That means, what if I tell you AE is 5? What's EC? Better have said 5, because they are the same. They have to be on the same line to be the same. Notice this marking and this marking are different. We only know the middle. Ooh, I'm erasing everything here. We only know the middle. So we don't know if the two lines are the same. We just know they bisect. Okay, one more theorem. I'm gonna have to put this in another video here.